Welcome 30-2. So I'm just going to go over this practice assignment number 1 here. Hopefully you've tried it already, and if you haven't, pause this video and try some of these questions out before we do them. This is your practice. A very good indicator of what you know how to do, and when you get to the assignment, you're not going to have one of these videos. All right, so the first little bit here is we're going to just talk about just creating a set, just a random set. In this one here, they want us to create a set of all the vowels in the alphabet that occur before the letter P. Okay, so to do this, what I'm going to first of all do is maybe find out what the alphabet is. All right, so I'll just load up with the alphabet here. I'm just going to change where that is. We'll put that over here. Okay, so all the vowels. So we're looking at just keywords here. We're looking at vowels before the letter P. So here's the letter P. So O is before that, and then just keep going backwards here. I, E, and A. You can see that A, E, I, O, and U. U is after P. So my set is just going to be A, E, I, and O. So here's my set for P. Okay. Natural numbers, if you remember actually I don't know if the video is here. That might be a future video. The next video talks about number systems. Natural numbers are numbers that are 1, 2, 3, 4, 5, 6, 7, 8, and so on, with no decimals, not including 0. 0 is a whole number. So natural numbers between 5 and 20, so numbers without decimals between 5 and 20, that are even. Okay. It says between those two numbers. Not the kind of keyword is between. This probably doesn't include the number 20. Even 20 is even, probably doesn't include it. The first even number after 5 is 6, then 8, then 10, 12, 14, 16, 18. And I'd probably stop there because it doesn't say inclusive. If it said inclusive, then I'd probably include 20 as well. X here is, or all the whole numbers less than, so this keyword is whole numbers, less than 20. So whole numbers include 0 as well, that are divisible by 6. Okay. So what it means to be divisible by 6 is that you can divide it and not get a decimal. All right. So I'm just going to pull up my calculator. All right. And we just start going down. Say 20. This is less than 20, so it's not going to include 20. So 19 divided by 6 doesn't work. 18 divided by 6. Yep. So 18 is a number. What you can do now, once you know what the one number is, you can just keep on minusing 6 from those numbers and just keep on getting the next. So the next one down would be 12, 6, and technically 0. You can talk about this in a later video if you want, but 0 is an even number. It's the most even number because if you go 0 divided by 2, it's 0. And I keep on dividing by 2. But it's also not a decimal number. So if I go 0 divided by 6, I get 0. It worked. It's not a decimal number. It's considered a whole number. So I would consider 0 to be one of our answers for this one. Okay, for the next one here, they just want us to talk about how do we create using set notation. I don't like the word builder, but it's there. To represent the intersection between A and B, not. So another way you could say this would be like, what is the complement of the intersection of A and B? So remember the word complement here is the same thing as saying not. So I want to know what the intersection of A and B are. So A intersect B, so that would be the builder notation or the set notation of that. And then I want not. So that's this little apostrophe that you see here. So that's the not symbol there. So you can see I put big parentheses around it because I want to do the intersection of A and B. Then I put a little comma, not, or the complement of all of that. What is the union of A, B, and C? So A, B, and C, and I want to do the union of all these. So I'm just going to put a bunch of U's between them. That's the union. So if that was like a 3 circles, I just want to represent these as a Venn diagram just to see if I can remember what they look like. So I have A, I have B. The intersection is this right in the middle. So this is the intersection right there. But what's not the intersection is everything that's outside of that piece. So all this red area here, that is not the intersection between A and B. So it's pretty much everything but that little piece that's in the middle. Now, if I did the same thing for my union one, I'll have 3 circles this time. And they might look like that. And then the union between all of them would be just all the circles, every piece on all the circles here. So that's what the union would look like. Okay. They can get more complex, but I'm just going to keep it to simple ones here. I'm not going to do some weird ones. And it might show up on some assignments. If you see one of those, you can just ask me those questions in the Google Hangouts here. All right. Or Google Meet, or class time. Okay. So here, let's say I consider these sets, X, Y, and Z, and you see that some of the numbers are common, like this X is a 2, this also has a 2, it's like 2, 4, 6, 8, 10. Even numbers, or multiples of 2, there's 2, 4, 6, 8, 10, and X as well. Looks like Y are just all the odd numbers, but then you notice that those are in there. So it looks like X is like our universal set, it has everything in it. So what this is saying here is when you see this kind of notation, this notation, that means, remember what that means? It means it's a set of, or a subset of. I'm going to sneeze just 1 second. Sorry. Now that means the subset of, subset. Oh, that's kind of a weird way to write that. Subset. Okay. Now if I put a line through it, it's kind of like saying not equal to. So remember that an equal, but this means not equal. So whenever I put a line through, it just kind of means not. So it's just saying, is this not a subset? So is 4 a subset, or is 4 inside of Y? Remember, that's what subset means. It's completely inside it. Is 4 inside of Y, but is 4 not inside Y? Because they're all similar, right? It means not. So is 4 inside Y? No. So this is a true statement. Okay. Is 8 inside of Z? So this is true. Okay. If it's false, then we have to explain why it's false. Is the intersection between X and Y, so X is all the numbers from 1 to 10, and Y being the odd numbers, is the intersection an empty set? I'm going to say that this is a false statement. And the reason behind that is because if this is X and Y is completely inside that one, so the intersection between the two is Y. So to correct the statement, the intersection between X and Y is Y, because they are completely inside each other, or Y is completely inside that other one. Now here it's saying, is Y a subset of Z? No, that's a false statement. Now, the reason that's a false statement because Y is not inside Z. There's no elements inside Y that is inside Z. There's nothing. To be this statement, Y has to be completely in there. So Z would have to have 1, 3, 5, 7, 9. So I could say Z does not have 1, 3, 5, 7, and 9 in it. Is Y. Y is not a subset. So this is a true statement. Y is not a subset of Z, right? Y is not inside. And even if they had some common pieces, it has to be completely inside. So if there's like a little overlap where one number wasn't out, so it still wouldn't be a subset. The union between X and Z here. Let's see what the union between X and Z. So remember the union of X and Z is just everything of those two pieces. So the union between X, and here's X, and Z is completely inside there. The union between those two would be all of X. Remember from the previous video or previous example there, union just is everything. It's all of X and all of Y, all of Z, sorry, not Y. So this would be, so this is a false statement because it doesn't have all of X. So it would have to have all of these elements. I don't know why it would stop at 5 all of a sudden. 8, 9, 10. So that would be the true statement. Okay. Question 4. We're just shading the areas in this Venn diagram that represents this. So this is the intersection between the two. So you should have already shaded what's in between them. This is the union. So you should have shaded everything inside both circles, including what's in between them. Okay, so that's the union. So this is the union between, not A and B. So what's not A? And this is the union, so there's just shading everything that's in both of those. So what's not A is this is not A. This includes all the outside pieces too that wouldn't be in those circles. That's not A. And what is B? I'm going to highlight B as well. B, that's B. So the union of all that would be the yellow and the green together. So if I get rid of B's, oops, get rid of B's piece here. Let me erase that. Okay. There we go. I can just highlight all of this. Oh. Okay. Highlight all of that. So that's what that would be. So not A, the union of not A and B. So here's the, oh, kind of talked about this already. So the intersection between A and B, but not. So the complement of that. So remember the intersection, you can go back to the first one, that's the intersection between A and B. So this one up here, and A. But what is not that? Well, it's everything that's outside that piece. So that's what this would look like here. Highlighting job is not the best. Can't really color within the lines here. I'll try my best though. Okay. Yeah, good. So let's think about this. So here's that set again. So we got all the numbers between 1 and 10. That's an X. Y are all the odd numbers. Z is all the even numbers. What's the intersection between X and Y? So the intersection, remember the intersection is what do they have in common? But because Y is completely inside of X, the intersection is Y. So 1, 3, 5, 7, and 9. So I'm just going to rewrite, I'm going to write that as a set notation here, or yeah, set notation. There you go. The union between X and Y. So the union between the two. Same example we gave before. The union between the two is all of those two bubbles. And since X has all the numbers already, it's really just X. Let's get it right. It's just X, really. Now, what's the intersection between Y and Z? Well, there's nothing in common because Y and Z, they would be like, if I were to draw the Venn diagram for this, here's X, here's Y, here's Z. There's nothing in common between the two because these are even numbers and, or sorry, these are odd numbers. These are even numbers. Technically, there wouldn't be anything else inside those other spots, but they're not touching each other. So that's an empty set. Yeah. So let's look at this next one here. And so I'm keeping looking over to the Google Classroom just in case some kids drop in once in a while. In a student survey, it's found that 110 students had cats or dogs. Right? 65 said they had cats, or dogs, sorry, and 72 said they had cats. So let's just label these two circles here. We got dogs and we got cats. I'm going to put the numbers up here. So this whole circle for cats has to have 72 in it. There's an X in here. We're trying to find that X here. Determine the number of students that both have cats and dogs. So that's going to be this X here. Okay. And I'm going to put a little number inside here, 65. So this whole circle, including the X, has to have 65 pieces. So whatever these two spaces had to add to 65, these two spaces had to add to 72. You notice that there's 18 kids out here that neither have cats or dogs, so that's already written here for us. Okay, so what I want to know first of all is how many people are in this space right here. If I were to do the union between the two, how many people are in there? So what I know already is that there's 18 out here. So I'm going to go 65. I'm going to minus 18. I'm going to pull out my calculator. 65 minus 18. I got 47. That's 47. Now, if I add the 65, oh, I don't know why I put 65. Sorry, I'm going to erase that. It should be 65. I was thinking of the dogs. It's 110 minus the 18. So 110 minus the 18, that's 92, sorry. So there's 92 kids that have cats or dogs, right? And then if I add the 65 and the 72 together, what I get, 65, I don't know why I put a 67 there, okay, plus the 72, I get 137. Add those two circles together. The problem is these two circles have this little X in between. You notice that these numbers don't match up. There's 92 kids that have to have cats or dogs, but then if I add these numbers together, it's 137. So there's a little bit of overlap because what I've added an extra X here. So the cats and dogs have an X in it. The cats have an X, the dogs have an X. If I were to add all that together, technically I have these two X's, but I want just the one X that's in there. So what we're going to do is subtract these two numbers. If I subtract these two numbers, I get 45. So I got 137 minus the 92, and I get 45. So this is X. That's 45 kids, right? It's what they have in common here. So I'm just going to double check here. So 65 minus the 45 would give me 20. So only 20 kids only have dogs. And then 72 minus the 45, 27. So 27 kids or students only have cats. Now, if I were to add all the numbers together just to verify to see hopefully this worked, 20 plus 45 plus 27 plus the 18, get 110. So I added my numbers together and it worked out. So what we were trying to find, determine the number of students that both have cats and dogs, 45. There you go. So we already answered the question before. I didn't have to answer this other stuff that's up here. Using the Venn diagram, let's determine what's inside set P. So set P is the whole circle P. So that's 1, 5, and 7, and 9 and 3. That's supposed to be a curly bracket there. All right, so it's the whole circle. The universal set is everything. So 1, 2, 3, 4, 5. You notice there's no 6 here. I don't see a 6. 7, 8, 9, 10, 11, 12. Yeah, it's all the numbers but 6 for some reason. Nope. All right, just 1 second. Not Q. So what's in not Q is everything that's outside of Q. Everything that's outside that circle, that's not Q. So that's 11, 12, 13, 14, and 15, and 1, 5, and 7. So that's everything that's outside of the circle. It includes what's inside P here. So what is not P or Q? Okay, so I'm looking for that. When it means P or Q, that's a union. If it's P and Q, that's going to be the intersection. Okay, so what am I looking for here? So I'm looking for everything that's not P or Q. So that's just pretty much everything that's outside. So P, the union between the two is all these circles. Is from here, it's all this stuff here. I'm just going to color on it now because I can. So what's not that? It's just everything outside the circle. So we got 11, 12, 13, 14, and 15. There we go. So that is the answers for the first assignment or the first practice. I'll upload that one, and I'll upload another video for practice number 2 in just shortly time here. Okay, I'll see you later. Bye.